You've felt this. The moment you start paying attention to your own breathing, it changes. The rhythm that was automatic becomes deliberate. The thing that was just happening now requires your involvement. You're not just watching anymore, you're participating, and you can't undo it. This isn't psychology. This isn't some quirk of self-consciousness. This is an echo of the central mystery that's haunted quantum mechanics since 1935. And if the idea that observation changes reality feels fundamentally wrong, if it seems like the universe shouldn't care whether you're looking, you're in good company. Erwin Schrödinger felt the same way. That's why he invented the thought experiment with the cat. But here's what most people miss. Schrödinger's cat was never about whether something could be alive and dead at the same time. That's the surface. The real question, the one that physicists still can't agree on, is this: what counts as measurement? What qualifies as observation? Why does measuring something seem to force nature to choose? The cat isn't the mystery. The act of measurement is. The connection between your breathing and quantum mechanics isn't obvious. Your breathing changes because you're consciously intervening in an automatic process. Attention disrupts the rhythm. But in quantum mechanics, something stranger happens. Measurement doesn't just disrupt a system. It seems to fundamentally determine what's real, not by touching it, not by disturbing it mechanically, just by measuring. That's what Schrödinger's thought experiment reveals. Let's start with what actually happens in the experiment, not the popularized version, the uncomfortable version. You have a sealed box. Inside, one cat, one radioactive atom, one mechanism that releases poison if the atom decays. The atom has a 50% chance of decaying within 1 hour. The mathematical formalism of quantum mechanics describes the atom as existing in superposition until measurement, both decayed and not decayed simultaneously. Not we don't know which, both states at the same time. Here's where it gets strange. If the atom is in superposition and the atom controls the poison mechanism, and the poison mechanism determines whether the cat lives, then according to quantum mechanics, the cat itself must be in superposition, both alive and dead, not metaphorically, not unknown, actually, physically, in both states at once, until someone opens the box and measures. Then, only then, does the superposition collapse. The wave of possibilities crashes into a single outcome. One outcome becomes real, the other possibility vanishes. And here's the part that makes this deeply strange. The mathematics says measurement causes this collapse, not time passing, not the box being sealed, measurement. The question isn't, how can a cat be both alive and dead? The question is, what counts as measurement? What is it about observing that forces reality to choose? This is where physicists started arguing, and never stopped. Because the standard interpretation, the Copenhagen interpretation, developed by Niels Bohr and Werner Heisenberg in the 1920s at Bohr's Institute in Copenhagen, requires something it struggles to define: measurement or observation. And here's what makes this deeply strange. The mathematics of quantum mechanics is the most precisely verified theory in human history. It predicts electron behavior to 10 decimal places. It explains all of chemistry, all of electronics, the behavior of matter at the smallest scales. The math works perfectly, except it contains a variable it cannot define precisely. Particles in superposition, wave functions, mathematical descriptions capturing all possible states simultaneously, like a spread-out cloud of possibilities rather than definite positions. Then measurement happens and collapse. One outcome. The wave function collapses into a single state. But what counts as measurement? What qualifies as observation? Is it the Geiger counter detecting radioactive decay? That's a physical system following physical laws. Why would it trigger collapse? Is it the photons bouncing off the cat and hitting a detector? Photons don't have intentions, they're just electromagnetic waves. Is it the electrical current in the detector? That's just electrons moving. Where in this chain of physical causation does measurement become special enough to reshape reality? The mathematics gives no clear answer. It simply requires observation or measurement without defining precisely what these are. It's like discovering that the fundamental equations of the universe contain a variable that works perfectly in practice but resists definition in principle. Pause for a moment. Feel what this implies. The equations work, the predictions are precise, but somewhere in those equations is a placeholder, measurement, that we can't fully define using only ordinary physics. It's there, it's necessary, but it's not like other physical quantities we can specify exactly. Now the question becomes, what could count as measurement? You might think, surely some system must qualify. A sophisticated measuring device, a computer recording data, something that can register information. But here's the problem. Every physical system that could measure the cat is itself made of quantum particles. The Geiger counter is made of atoms that follow quantum mechanics. The computer's transistors are quantum systems. If measurement requires something special that ordinary physical processes don't automatically provide, then these systems don't obviously have it either. They're just more quantum states, more particles in superposition. This creates an infinite regress. If the Geiger counter needs something to collapse its wave function, and the detector measuring the Geiger counter needs something to collapse its wave function, and that detector needs yet another, where does the chain stop? This is where some physicists, notably Eugene Wigner and John von Neumann, proposed something radical that would become one of the most controversial ideas in quantum mechanics. Maybe consciousness is special. Maybe awareness is what breaks the chain. Maybe something about conscious observation provides what mere physical measurement cannot. But here's the crucial point. This was never Bohr's view. As early as 1927, Bohr said it makes no difference whether the observer is a man, an animal, or a piece of apparatus. The consciousness interpretation became a notorious minority position, and one that most physicists today reject. In a 2011 poll at a Quantum Foundations conference, where physicists who specialize in these fundamental questions gather, only 6% believed consciousness plays a necessary role in collapse. Yet the question remains, if not consciousness, then what? What makes measurement special? This uncertainty about what counts as measurement is what drove other interpretations. Because if the problem is that you can't define measurement without invoking something mysterious, consciousness, observation, some undefined threshold, maybe the solution is to eliminate measurement as a fundamental process entirely. Hugh Everett III asked, what if there's no collapse? What if every quantum possibility actually happens, but in separate, branching universes? When you open the box, you don't collapse the wave function. You split into two versions of yourself. One version finds a living cat, another finds a dead one. Both are real. Both are you. Neither knows about the other. This is the many worlds interpretation. It eliminates the measurement problem entirely by eliminating collapse. No special observers required, no consciousness needed, just infinite branching realities, most of which you'll never access. Others took a different approach. Keep collapse, but remove the need for observers. Make it automatic. Physicists like Giancarlo Ghirardi, Alberto Rimini, and Tullio Weber proposed spontaneous collapse models, GRW theory. Maybe wave functions collapse on their own, without any measurement or observer, when quantum systems reach certain thresholds of complexity. A single particle stays in superposition indefinitely. A trillion particles, like a cat, collapse almost instantly through an objective physical process. Consciousness doesn't matter. Mass and entanglement do. These alternatives solve the measurement problem, but notice what they replace it with. Either infinite unobservable universes or mysterious new physics that triggers collapse for reasons we're still trying to understand. The question remains, just reformulated. Quantum mechanics is the most precisely verified theory in the history of science. The predictions are accurate to 10 decimal places. It works. It underlies all of chemistry, all of electronics, all of modern technology. Either measurement is a fundamental process we don't fully understand, or reality splits into infinite branches we can't observe, or quantum systems spontaneously collapse through mechanisms we haven't discovered. No interpretation solves the problem without cost. Each trades one mystery for another, and beneath them all is the same disturbing recognition. The mathematics that describes reality with perfect precision contains a gap where measurement or observation occurs, a place where something happens that the equations cannot fully account for using only the ordinary concepts of physics. Some thought consciousness might fill that gap. Most physicists now think otherwise, but the gap itself remains, not because physics is broken, but because at the boundary between quantum and classical, between possibility and actuality, something happens that we can describe mathematically, but not explain conceptually. And nobody knows exactly what. So, who kills the cat? In the Copenhagen interpretation, measurement does. But what counts as measurement remains unclear. Something about the act of observing forces nature to choose, but the theory doesn't specify what observing fundamentally means. In many worlds, nobody kills the cat. Both outcomes happen. You just split into two observers, one mourning and one relieved, neither aware the other exists. In spontaneous collapse theories, the cat's own complexity kills it, or rather, the system's mass triggers collapse before you arrive. You're just witnessing what already happened. 3 interpretations, 3 different answers, same mathematics underneath. And if this ambiguity bothers you, if it feels wrong that physics should work perfectly without explaining what measurement is, then you understand why Schrödinger proposed the experiment in the first place. Not to celebrate quantum strangeness, to show that something is missing, that the theory is incomplete in a way we haven't yet resolved. Remember your breathing, how attention changed it from automatic to deliberate. That's interference, you inserting yourself into a process. But in quantum mechanics, measurement doesn't just interfere mechanically, pushing atoms around, adding energy. It determines which of multiple coexisting possibilities becomes actual. That's categorically different from ordinary physical interaction. The cat in the box is both alive and dead until something measures it. But the deeper mystery is what measurement means. What gives a process, any process, the power to turn superposition into singular reality? Maybe it's consciousness, maybe it's complexity, maybe it's something else entirely. The mathematics doesn't tell us, it just shows us that measurement matters in ways ordinary physics can't fully explain. The question isn't whether the cat is alive or dead. The question is why measuring makes a difference that physics can describe but not explain. And that question is still open.